Hello students, welcome to the concept Digital Image Watermarking. We all know the watermarking is for safety of the documents or for safety of the videos or the images. Here the watermark is an invisible signature embedded inside an image to show authenticity or proof of ownership. When you introduce watermark to your text or image or video, it discourages unauthorized copying and distribution of images over the internet. It ensures a digital picture has not been altered. And to search for the watermark, we need a separate software. So that is the reason watermarking is very much important for the security of the documents or the images or the video. It is nothing but protecting an intellectual property. We'll see the definition. Digital image watermarking is the process of inserting data, means a watermark, into an image in such a way that it can be used to make an assertion about the image. Means for security for the image. See the image, see the diagram. This is the image and a watermark is added and you're getting watermarked image. So if you add a watermark to the image, automatically you'll get protection for our image. Watermarked images protect the rights of their owners in different ways. These are different ways of protecting the documents of the owners: copyright identification, user identification or fingerprinting, authenticity determination, automated monitoring, and copy protection. Please read all these things. Very easy to understand. Now coming to the visible and invisible types of watermarks. Visible watermark is an opaque or semi-transparent subimage or image that is placed on top of another image, that is the image being watermarked, so that it is obvious to the viewer. Visible watermark is a watermark simply which can be seen by the viewer. Okay. Yes, the examples of television networks often place visible watermarks fashioned after their logos in the upper or lower right hand corner of the television screen. Yes, we are all seeing visible watermarking typically is performed in the spatial domain. Okay, spatial domain means in the XY domain. Coming to the example of a simple visible watermark. The watermarked image FW can be expressed as a linear combination of the unmarked image F and watermark W using this formula. FW is equal to 1 minus alpha into F into alpha into W. What is FW? Watermarked image. What is F? Yes, the original image which is not having any watermark. And what is W? Is a watermark. And alpha is a constant which controls the relative visibility of the watermark and underlying image. If alpha is 1, the watermark is opaque and the underlying image is completely obscured. As alpha approaches 0, more of the underlying image and less of the watermark is seen. In general, alpha is between 0 and 1. Okay, here if alpha is 1, I can see only the watermark, we can't see the original image. If alpha approaches 0, we can see more the original image and less watermark. Okay, and in general, alpha is between 0 and 1. If you see this example, this is the first image is the watermark and the second image is the image with the watermark and with alpha 0.3. And difference between the original image Lena and this watermark image is this. Yes, the difference between the original image and the watermarked image is only the watermark. That is the reason we are getting only the watermark. So this is about simple visible watermark. Coming to the invisible watermark. Unlike the visible watermark, invisible watermark cannot be seen with the naked eye. Fine. They are imperceptible but can be recovered with an appropriate decoding algorithm. Invisibility is assured by inserting them as visually redundant information. We know the visually redundant information that the human visual system ignores or cannot perceive. Okay, the watermark must be ignored by the human eye. Okay, then only you can call it as invisible watermark. Okay, then fragile invisible watermarks are destroyed by any modification of the images in which they are embedded. Fragile type of invisible watermarks are modified if there exists any processing on image. And there exists another type of invisible watermark, most invisible watermarks, which can't be modified by the image processing algorithms. See the example, the first one, watermarked image. Okay, this is the watermarked image, and the B is the extracted watermark. And the image C is the watermarked image after high quality JPEG compression and decompression. This is the watermarked image, and this is the watermark, extracted watermark. And this is the image after compression and decompression with JPEG. And from this, if you want to extract the watermark, then you are going to get this as the watermark. Means why the watermark is changed, why you are not able to extract this watermark at this point, because this is the image which is watermarked and this is modified image. What is that modification? Compression and decompression. Okay, so that is the reason we can't able to extract the watermark. What type of watermark it is? It is nothing but fragile invisible watermark. Coming to the typical image watermarking system, it consists of two parts, encoder and decoder. If you see the encoder, in the encoder concept, we have image, the original image Fi and the watermark Wi. Yes, the two are combined to get the watermark image Fwi. Yes, the encoder inserts watermark Wi into the image Fi, producing a watermarked image Fwi. That is the encoder concept. Coming to the decoder, see the decoder. The decoder takes a watermarked image Fwi or a normal unmarked image Fj. See this. The input for the decoder is Fwi or Fj. Fwi is watermarked image and Fj is the image which is not watermarked, means the original image. And what is happening then? It tries to extract the hidden watermark and check whether the watermark is present. When the image has no watermark, it is written as W5, means no watermark. See this. See this. This is the watermark extraction phase. Yes, if the watermark is present in the given input image, then yes, it will give as Wj, means there exists watermark. If there is no watermark in the input image, then it results W5, means no watermark. Then after the extraction of the Wj, yes, it checks whether this extracted watermark is same as that of the original watermark which is included in the encoder side. Yes, see this. If Wi is visible, okay, then decoder is not needed because anyone can see it. Fine, means if this encoder means in the watermarked image, if you are able to see the watermark, then no need of decoder because we can see. But when the decoder is needed, when the watermark is invisible. If Fi and Wi are used, the watermark system is known as private or restricted key system. If not, it is a public or unrestricted key system. Suppose in the decoder, to extract the watermark which you included in the encoder, if you need Fi and W, means only with the help of these two, if you are able to extract the watermark, then the system is known as private or restricted key system. If the decoder is not used this Fi and Wi to extract the watermark, this is called public or unrestricted key system. Okay, then yes, finally the decoder confirms the watermark by comparing the extracted pattern Wj with the original watermark Wi. As I said, this is the extracted watermark Wj. Yes, this is the original watermark Wi. Yes, this decoder compares this Wj and Wi because the extracted watermark must be equal to the original watermark. Okay, then that is the purpose of decoder. How to check it? See this. This comparison is done using correlation, means a similarity measure. If the correlation value is above a threshold, the system decides watermark is present, otherwise watermark is absent. So there exists this watermark detection concept. Yes, if it checks the similarity between the extracted watermark Wj and the original watermark Wi, if the similarity is greater than some predefined threshold, then we can say the system decides watermark is present and it is equal to the original watermark, and otherwise the watermark is absent and there is no watermark. The threshold sets the degree of similarity that is acceptable for a match. Okay, this is about the encoder and decoder. Okay, so encoder simply includes the watermark to the original image, and decoder decodes, means it extracts the watermark. Okay, so to extract the watermark, first it checks whether the given input image consists of any watermark or not. Yes, if there is no watermark, it results W5. If there is watermark, it results WJ. Okay, it means it extracts the WJ. Then whether this extracted WJ is same as that of the original WI, yes, it has to do some comparison. That is the reason there exists mark detection. Here from this side we are giving WI watermark of the original. Yes, this mark detection at this mark detection stage, it compares the extracted WJ and original WI. If the similarity is greater than some predefined threshold, then decoder gives there exists a watermark and which is identical to the original watermark. If similarity is less than threshold, it tells us there is no watermark. Okay, so this is about a simple image watermarking system. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.